Dear participant, good afternoon. Welcome to Symposium. We are excited to welcome you to the International Conference on Electrical Electronics, Energy and Computer Science, a premier global platform that brings together experts, innovators, and professionals from diverse engineering disciplines. This conference is designed to foster interdisciplinary collaboration and highlight the latest advancements across a wide range of fields, including electrical engineering, electronics, energy systems, computer science, mechanical engineering, mechatronics, automation, and biomedical engineering. Thank you for your scientific contribution and support the symposium. First paper belong to dear Ömer Rashid.
Dear sir, hello. I I sent you email for I already
Okay.
stopped. Yes,
Ee,
fast stop.
okay. Dilan Kaktaş Ateş. Okay.
Yes,
If you are ready, you can start your presentation.
yes. If you want, I'm started. Thank you so much. This organization, dear professor. I share my
Okay.
window.
Share your screen.
Yes, uh,
You have 10 minutes, please.
yes. Thank you so much. And full scan. Not wait. Will you see my screen?
Yes.
Yes, okay. I'm started now. Okay.
Okay.
Today, I present my presentation is uh, wait. Sorry, so sorry. Today my presentation is this study presents a comprehensive literature review on the digital preservation of historic building by focusing on the integration of historic building, information modeling, artificial intelligence, and virtual reality. Historic structures are under continuous threat from the natural disasters, human negligence, wars, and environment decay. Traditional preservation approach do valuable often fall short in terms of time efficiency, cost effectiveness, and accessibility. The integration of digital tools, a multidimensional solution enabling accurate documentation, simulation of environment impact, and data-driven decision making. Uh, and our overview and introduction problems, literature, objectives, hypothesis, methodology, result, conclusion, and recommendations. Introduction. This study focuses on historic building information modeling, HBIM, artificial intelligence, AI, and virtual reality in the digital restoration of historic building. It evaluates the opportunities these technology provide compared to conventional preservation methods. Through a quality literature review, the study examines international HBIM application and demonstrates how digital tools enhance documentation, interdisciplinary collaboration, and sustainable conservation of cultural heritage. Problems. Traditional preservation methods for historic building are time consumption, costly, and limited accessibility and data management. These methods often fail to provide accurate, updatable documentation and struggle with the data loss. human error, and lack of integration among disciplines, there is a growing need for digital approach such as HBIM, artificial intelligence, and virtual reality to overcome these limitations and ensure a sustainable conservation of cultural heritage. Objectives: this study aimed to examine digital restoration practice for the preservation of historic building by focusing on the integration of historic building information, HBIM, artificial intelligence, and virtual reality. It seeks to evaluate the opportunities offered by digital technologies compared to traditional preservation methods and to demonstrate how these tools enhance documentation, analysis, and sustainable conservation of cultural heritage. Hypothesis: integration of HBIM, artificial intelligence, and virtual reality into heritage conservation will increase efficiency, accuracy, and sustainability in restoration process. These digital technologies will facilitate interdisciplinary collaboration among experts. They will also enable data-driven decision making for the monitoring, documentation, and restoration. Consequently, the use of digital tools will strengthen the long-term preservation and cultural continuity of historic building. Literature review Perry distinguishes between digitization and digital preservation, noting that true preservation requires long-term data management, ethical and managerial responsibility. Conway and Smith emphasize that digitizing alone doesn't ensure authenticity or sustainability, while Galloway highlight the higher cost and complexity of preserving digital archive, and John Hallett introduced at HBAM-based digital twinning technology that integrates tangible and intangible heritage data for preventive conservation. Methodology Our study methodology will research approach. First of all, quality literature review, data source, academic articles, official reports, institutional documents, focus topic, historical building information modeling, artificial AI and virtual reality, focus context, BIM application under the UK's initial studies published by Historic England, analysis process, comparative evaluation of traditional preservation, and interpretation all of them, and conclusion: identify how interdisciplinary approach contribute to digital restoration and hence sustainability in conservation process. Application and finding: first, evaluation of traditional historic building preservation processes conducted according to conservation-oriented zoning plan regulation and heritage protection statutes, includes stages of survey, releve, restitution and restoration, supervised by regional conservation boards, architectural drawing prepared by contractors, and check on site during various implementation stages. Challenge: time loss due to complex bureaucratic procedures, high error margin during inspections, difficulty in archiving physical data, limited accessibility to advanced technologies, and digital archiving methods and HBIM implementation. With the integration of technology into all aspects of life, digital data storage systems are becoming increasingly common in archiving practice. The fundamental advantage of digital methods or traditional ones include time efficiency, cost effectiveness, reduced labor requirements, prevention of data loss, and increased accessibility. A benefit of HBIM and virtual reality technologies. The key innovation and advantage introduced by digital modeling include preservation of physical documentation of historic building in digital environments, thus preventing data loss, secure access to all building, reduce need for physical site inspection, thorough the ability to update structural control process via HBIM platform, resulting in time saving, promoting wider adaptation of digitizing in historic preservation practice in Turkey in comparison to current traditional methods. And conclusion: preservation of historic building is an interdisciplinary process that should combine physical restoration with the digital technologies. Tools such as HBM, AI, VR, digital twins, photography, and laser scanning improve documentation analysis and sustainable conservation. HBM offers holistic 3D models integrating geometric, material, and cultural data, ensuring efficient and data-driven conservation. All supports the detection, material selection, and maintenance planning, while we are enhanced visualization and public engagement. Digital twin systems enable real-time monitoring and preventive maintenance through time-based 3D comparisons. A SWOT analysis identifies the strength, weakness, opportunity, and threats of applying digital technology in heritage preservation. See next slide. And for last one, table one SWOT analysis of digital technology in the preservation of historic building, internal factors and external factors, strengths. HBIM enable detailed and holistic digital documentation of historic building. AI optimizes the major detection, material selection, and maintenance planning. VR integration supports decision making through immersive simulations, multidisciplinary data integration, geometric, historical, material, and cultural layers, opportunities, virtual preservation, and educational touristic reuse of cultural heritage, eligibility for international funding and supports from EU, UNESCO, etc. Growing academic interest and evolving digital conservation standards enhance public engagement and awareness of cultural heritage. Weakness, HBM is more complex than BIM for new construction due to irregular geometric decayed elements. High cost and technical expertise required for advanced tools. Lack of standardization in digitizing historical structures. Limited digital archiving infrastructure in some countries like Turkey. And threats depends on technology, poses risk of software incompatibility and data loss, digital security and long-term sustainability challenge, inadequate legislation and interagency coordination, inaccurate modeling may lead to flawed restoration decisions. Reference and thank you so much to professors. If you want questions.
Thanks for your presentation. Dear
Thank you so
Qasim, do you have any question about the study? Okay, no question. Thank you again.
Thank
I
you
wish
so
you
much.
success.
I leave the presentation, so sorry. I arrived my bus, dear
Okay,
professor.
okay,
Do you let me?
okay.
Okay, thank you so
Mm.
much.
Have a good day.
Thank you.
Next paper belongs to dear Ömer Rashid.
Good afternoon.
Hello. Are you ready to present?
Yes,
Okay, you can start your presentation by sharing your screen.
thank you.
You have 10 minutes, please.
Okay, I will take it. The presentation is on your screen.
Yes.
Hello, everyone. I am Dr. Omar Fitian. I am from University of Baghdad. My script title is Enhancing Network Security with RNA-based intrusion detection and COCO search algorithm. Starting by the introduction, the usage of internet is widely used by people, companies, and universities. And this usage is also increase the attack types and attacks, numbers of attacks. And therefore, there is many security systems that use to secure the computer or the network. One of these systems is the firewall. The firewall is still not very effective because it's only detect outside attack and a lot of viruses and worms and other types of malware is entered to the computer. Another system is antivirus program. The antivirus program is the first protection layer, but when a new virus is appear, there are when you make a scan for your computer, we cannot detect it because the dataset is not updated yet. Therefore, the companies and the big universities use a system called intrusion detection system, which is a second layer of protection. Intrusion detection can be defined as it is a software or a device that used to monitor the computer or the network from malicious activity. Intrusion detection system can be classified either anomaly or misuse. For anomaly, intrusion detection system is based on user behavior. The main advantage of this system is can detect new attacks when it appears, but the most drawbacks or the limitation of anomaly intrusion detection system is the high of false alarm rate result. False alarm rate, that means it is normal record that classify misclassified as attack. The second type is misuse detection, which is based on attack signature. The detection rate is high, but the main drawback of this type is when a new attack is appear, this system like antivirus cannot detect it because there is no attack signature with their dataset. The materials and method. The proposed method is an anomaly intrusion detection system using RNA encoding with Coco search algorithm. These two combination of this algorithm is used to enhance the pattern matching of the new proposed model. Sorry, this done based on using CICEEECS 2017 dataset, which is a new dataset that include new types of attacks. The proposed system consists of 4 steps, as shown in Figure 1. The first step is the data selection and pre-processing. The second step is RNA encoding. The third step is behavior key extraction. And finally, the classification using Coco search algorithm, or called CSA. The first step is used, as we said, we used CICIDS dataset. This dataset is consists of different types of attacks. We have normal, we have ping, we have bot, denial of service, distributed denial of service. We have FTP, we have alternate, infiltrating, port scan, a web attack, and the SQL injection, and XSS. This dataset is separated or divided into 2 groups. And the first one is for training, and the second one is for testing. Then the next step is the RNA encoding. We suggest a new RNA encoding table by looking for all record feature selection, where each record of CICIDS dataset is consists of 83 features. The table 1 show the example of one feature or all possible feature that in one record we found flow ID, we have 83, and an example for each one. As you're shown in table 1, that all the value is just a digital or a numerical from 0 to 9. Therefore, we have 10 values. We can convert it to RNA encoding. If RNA encoding is consist of A, C, G, and U, just 4 characters. 10 character or 10 value can be represented by 2 RNA encoding. 2 RNA encoding because this 2 RNA encoding or 2 character can handle all these possible value. For example, the 0 is converted to CC, 1 is converted to CG, and so on for all value. To understand the encoding more, the first one is the example of network traffic. One of network traffic of the used dataset, training or testing, the same. We convert it to RNA encoding, where each number is converted to RNA encoding. The third step, after we convert all training dataset to RNA sequences, we use a Coco search algorithm to extract the behavior keys. We said that the anomaly intrusion detection system is depending on user behavior. After we select the best key, we go to the final step, where testing dataset is also converted to RNA encoding, then applied CSA to search for the key. If we found the key in the network traffic or the tested network traffic, this key or this network traffic will be classified as normal. Otherwise, will classify as attack. That means the proposed system has 4 steps. First, we use the CIDS 2017 as dataset. We processing it and convert it to 2 datasets. One for training. Training is used to select the key, while the testing is used to classify the network traffic, either attack or normal. Result and discussion. The performance evaluation of the proposed system is done based on detection rate for each attack separately, or detection rate for all attacks, false alarm rate, accuracy and the time for encoding, and time for classification. The equation 1, which is detection rate, R, is classify the network traffic and check if the TB is representing the number of attack record that correctly classify as attack. The false alarm rate is the number of normal records that misclassified incorrectly as attacks, and the accuracy, the number of attack records that correctly classify attack plus the number of normal attacks that classify correctly to normal over the total number of record or testing record. Also, the time in second for encoding, convert all the network traffic to RNA sequences, and also classification time, the time needed to classify the network traffic, either attack or normal. The obtained detection rate results for each attack separately are shown in Table 2 and Figure 2. We can show that we can see that the infiltrating attacks SQL injection has 100%, and the least attack result, detection rate result, is for both, it's 86. While the detection rate, false alarm rate, and accuracy for all records, for detection rate is equal to 92.84, and false alarm rate is 19.6, and the accuracy is 19.22. Also, the time for encoding for all testing dataset, which equal to 1,000 records, is equal to 74.5 seconds, while classification time for all 1,000 records are equal to 13 seconds. Also, the RNA encoding time and the classification time for one record only is equal to 0.00745 and 0.003 seconds, respectively. The conclusion, in this paper, we propose a new intrusion detection system by combining both RNA encoding and COCO search algorithm, where the proposed algorithm is a normal intrusion detection system based on user behavior. This done by using CIDS 2017 dataset. The achieved results show that the proposed system is good compared with other systems. For future work, we can perform integration between COCO search algorithm and other optimization algorithm, or also can enhance it by suggesting another encoding method, or also can expand it to cover more network topology to enhance the overall security of the network. That's all. Thank you. Any question?
Thanks for your presentation. Dear participant, do you have any question about the study? Okay, no question. Thank you again. I wish you success.
Thank you.
Next paper belong to dear Ömer Bafagas.
Hello, everyone.
Hello,
I am
present.
I'm ready.
You can share your screen.
Okay. Can you see anything? Is it
Yes,
shared?
yes,
Can I start?
please.
Hello everyone. I am Omar Wafakas. I'm a student in Bursa Technical University in Turkey at Bursa City. Our paper is about simulation based analysis of A star, RTT star, genetic algorithm and colony optimizations algorithm for autonomous robotics. Abstract. This study compares for path planning algorithms A star, RTT star, genetic algorithm, and colony optimizations tested on 25 50 grids with varying obstacle densities. Uh, as A star faster genetic algorithm and anti-colony optimizations most flexible but computationally expensive. Path planning is vital for autonomous robots and intelligent systems. This work evaluates deterministic A star, probabilistic RTT star, and meta-heuristic genetic algorithm and colony algorithms under identical conditions. So why path planning matters? Path planning is the brain of robots. Selecting the right algorithms change how efficiently our robots move. Research motivation and objectives. Compare A star, RTT star, genetic algorithm, and colony optimization in multiple environments. Identify trade-offs between speed, path optimality, and cost. Uniform start goal and identical test setup. Uh, Measured path length, computations time, success rate, stability, and we compare them all. Experimental setups, environments 2550 static grid maps, used hardware Intel Core i5 12500 high with 8 gigabyte RAM and RTX 3050 titaniums as a graphic card. Matrix path length computations time, success rate stability, and used software is Python. Include grids figures. So the algorithms were compared in this paper for paradigms. A star deterministic Heuristic search, RTT star probabilistic sampling, and genetic algorithm in voluntary optimization, and ant colony is swarm intelligence. While A star is rule-based and uh, efficiency meteorites like GA and ant colony optimization mimic natural to find creative rules. So genetic algorithm and ant colony are artificial intelligence, so they can improve the path with the time. So they need more time to get an amazing path. The first algorithm is A star algorithm. Uh, an expanded node based the sum of the path cost estimated distance to the goals. It always chooses the most promising node, which makes it fast and optimal in structured maps. The second algorithm, RTT star algorithm, randomly samples the environments and connect nodes to form a tree in continuously rewire connections to find short path given flexible and adaptive rules. And the third algorithm is genetic algorithm. The genetic algorithm evolves a population of paths through selection, crossover, and mutation. It gradually improves each generation to find the best path, but it is slower due to iterations. And the last one is ant colony optimizations. Simulates how ants find food by leaving pheromone trails. The stronger the trail, the more likely other ants will follow, helping the algorithm converge to the best route. Simulation parameters. A star with methane heuristic, so fast. RTT star with one step, and it's reward the reduce of cycle with 4 steps with 800 iterations. The the genetic algorithm with 300 population and 500 gens with high cost. Ant colony, we used 60 ants with phenomenon effects with 0.5. So we compared the four algorithms at the same path, at same different path with different density. The first one, as we can say, we can see the A star algorithms get the RTT star algorithm get the shortest path, but the A star algorithm get the same path with less time. So as in the first map, A star is the most efficient and stable algorithm for medium obstacle density map. In the second map, it's high density, and we say the conclusion of the second map is collected maze-like environments, deterministic methods like A star maintain. So we can say that A star can get the same path in every time, but the another algorithms can be changed because they are depend of probabilities. And the second map is a low density. We say in open spaces with four opticals, deterministic algorithm A star dominated in both spin and optimality. And the last map is vertical barrettes. We say for narrow corridors and vertical barrettes, A star remains efficient. RTT star performance well with extra cost, and ant colony optimizations provides a smooth path but longer path. Discussion. A star is ideal for low and middle complexity. RTT star is ideal for handless complex maps. Genetic algorithm and ant colony is flexible but computationally demanding. So thank you for listening to the presentation.
Thanks
I'll be
for your
happy to.
presentation. Dear Pasim, do you have any question about the presentation? No question. Thank you again. I wish you success.
Thank you.
Next paper belong to dear Fatma Çakıroğlu.
Yes, I am here.
Okay. If you are ready, you can start your presentation.
Um,
You can start your presentation now.
yes. Mm. I'm starting.
Okay.
Hi, everybody. I am Fatma Çakıroğlu. I am a PhD student and also a lecturer at Kayseri University. My research topic is a benchmark study on classical data augmentation for image classification with custom CNNs. The purpose of the study, in the study, the performance effects of data augmentation methods, translation, rotation, zoom, on the CI FAR10 datasets were investigated with the custom CNN model. Introduction, deep learning has achieved significant success in visual recognition and classification problems. However, in cases of limited data, overfitting can occur. Data augmentation provides a solution to this problem. Limited data reduces the model's ability to generalize. Data augmentation methods can be used to increase diversity, resulting in more balanced learning. Literature review to overcome this limitation, various data augmentation methods have been widely proposed and applied in the literature, aiming to improve model performance in scenarios with limited data. Shorten aim to improve model performance when working with limited data sets by using image data augmentation techniques to prevent overfitting in deep learning models. Khalifa conducted a comprehensive literature review on data augmentation techniques used in deep learning approaches for digital image. Wang and Price, they comprehensively studied various strategies aimed at improving the classification performance of handwritten digits in the MN IST datasets using animal classification such as dogs and cats. Purpose of the study examining the impacts of data augmentation methods on model performance, comparing augmented and baseline data on the CIFAR 10 datasets. Materials and method dataset contains 60,000 32 and 32 color image includes 10 classes: airplane, car, bird, cat, deer, dog, frog, horse, sheep, and truck. Figure 1 image from the original datasets. Data augmentation methods used in the study: random flip, random rotation, and random scaling. Random flip, one of the image data augmentation techniques. Flipping is a simple yet effective method that creates new samples by reflecting images along the horizontal or vertical axis. Random rotation, in the study, a slight rotation approximately plus or minus 18 degrees was applied. Random scaling, in the study, image were randomly zoomed in or out within the range of minus 10%, plus 10%. And figure 2, data augmentation applied to the image in figure 1. Custom CNN with two architecture focusing on achieving high learning capacity while integrating powerful regularization techniques. We designed a custom CNN architecture, hereafter referred to as the custom CNN. The architecture is structured as a sequence of 3 convolutional blocks followed by a dense classifier header. And figure 3, custom CNN model block diagram. Input 32 and 3 color images. Convolutional blocks consist of 3 blocks. 2D layers, real U activation, patch normalization, dropout, and max pooling are applied in each block. The number of filters increases as the layer depth increases. Flattened feature maps are flattened for the fully connected layer. Dense block 512 neuron real U layer batch norm and dropout. Output layer softmax activation for 10 classes. Training hyperparameters, a 5-fold cross-validation method was applied to ensure reliable evaluation of model performance. At each iteration, the dataset consisting of 6,000 image was split into training subsets of 48,000 images and validation subset of 12,000 images. Training was performed using the Adam optimization algorithm, which improves generalization accuracy. The training process was terminated early when the validation loss did not improve within 10 epochs and the model weights with the lowest validation loss were restored. Furthermore, when the validation loss didn't improve within 5 epochs, the learning rate was reduced by a factor of 0.2 down to a minimum value of 1 times 10 to the minus 6. And evaluation metrics, accuracy, weighted precision, weighted recall, weighted FBR score, and all metrics were calculated by averaging 5 folds. Table 1, hyperparameter configuration, hyperparameter validation strategy, optimizer, entire learning rate, weight, decay, loss function, batch size, maximum epochs, or stopping patient, reduce patient and reduce factor. And figure 4, confusion matrix of the results for the custom CNN and data augmentation cases without and with data augmentation respectively. The graph shows that the model with data augmentation provides improvement in accuracy. And table 2, comparative performance of custom CNN with and without data augmentation. Table 2, which includes numerical results, shows that data augmentation provided a 2.5% increase in accuracy. The model's generalization ability was strengthened. Training time was extended by 8%, but more stable results were obtained. In summary, this study performance classification using a custom CNN model on the CIFA R10 image dataset. Data augmentation was performance using classical data augmentation methods such as random horizontal flip, random rotation, random scaling, and the models were retrained using the augmented dataset. Experimental results using the CIFIR10 dataset and the augmented dataset demonstrate that data augmentation provides a significant and valuable improvement in classification performance for the custom CNN architecture on the CIF AR10 datasets. And reference where thanks for listening.
Thanks for presentation. Dear participants, do you have any question about the presentation? Okay, no question. Thank you again. I wish you success. Next paper belong to dear Güllü Akkaş.
Hello.
Hello. Are you to present?
Okay, I'm ready and I can share my bir kapatalım mı?
Please, you can share your screen.
I can share my screen now. Can you see now?
Yes. You have 10 minutes, please.
Okay. I'm Güllü Akkaş. Welcome to our season. Our subject, our topic is about digital twin in education, digital twin technology in vocational education machinery, processes for digital twin transformation and CNC rotor case study. And she's my co-worker, Feyza Gürbüz. We prepared this presentation together. Presentation outline, in this page you can see this page show that our outline, introduction, examples about literature and digital twin and education, digital twin preparation processes and conclusion. First of all, I want to start with introduction about my topic and my subjects. Digital transformation in industry changed traditional models, creating efficiency, innovation, and added value. Digital twins, the key technology of Industry 4.0, represent virtual copies of physical systems using real-time data. In machinery manufacturing, digital twins enable integration, self-management, and data-driven decision-making. In vocational education, they enhance learning efficiency through simulations, data tracking, and personalized programs. The study proposes active, hybrid, and gamified learning approach to adapt machine training to modern technological developments. In this figure, show that workflow of classical approach of vocational training, basic theoretical training, practical applications, workplace experience, regular assessments, professional ethics training, updated course content, and certification. Yes, digital twin technology application examples and literature. Digital twin technology originating in the aerospace industry has become a core component of Industry 4.0 and smart manufacturing. It supports the entire product life cycle, the design phase, optimization, validation, feedback, etc., production phase, resource management, process control, business processes, maintenance, real-time monitoring, decision support, and divestment phase, waste recovery, and innovation. Research across sectors, from autonomous driving to industrial robotics, demonstrates its value in forecasting, optimization, and data analysis. Digital laboratories built on these models offer secure simulation-based learning environments that strengthen vocational education. Ultimately, digital twins enable data-driven training, enhance process-oriented skills, and promote Industry 4.0 compatibility within technical education systems. Digital twins and education. Digital twin technology has become a key educational innovation, especially in STEM-based vocational training. While industrial revolution have continuously reshaped workforce skills, Industry 5.0 emphasizes personalized, experience-driven learning supported by AI, AR, and digital twins. In healthcare, digital twins integrate real-time data and enable virtual simulations to enhance training quality and patient safety. In technical fields, digitalized laboratories offer flexible and interactive learning alternatives where physical labs are limited. In engineering education, digital twins allow students to model complex systems, apply theory to practice, and gain experiential understanding. A systematic workflow defining machine parameters, modeling, synchronizing with real data, and creating training scenarios supports the development of qualified industry-ready graduates. Yes, in this figure 2, shows that digital twin-based machine area vocational training workflow. Physical properties of the machine park are determined. All parameters, for example, size, speed, weight, model capacity, sensors, motors, every part of this machinery, machine is physical properties. We can determine in this part these parameters: behavioral and functional modeling, cutting force and vibration analysis, servomotor motion dynamics, and tool wear, etc. Creating a digital twin environment. In this stage, we create digital twin environments with use OPCUA, for example, dashboard. In this stage, we can create this area. Integration with real-time data. We need in this part real-time data, and we integrate all of them, OPS and S7 to 1200 Siemens PLC we can use in this part. Scenario-based training content design, parameter optimization scenarios. Students receive hands-on training in a virtual environment, performance and skill development monitored, updates training content based on feedback, preliminary assessments before transition to physical environments, and creates a graduate profile ready for real applications. Digital twin preparation processes. This study defines digital twin preparation processes through the integration of virtual modeling, communication platforms, and PLC programming. A CNC router is used as a model to illustrate digital transformation in production, maintenance, and education. The virtual model designed in SolidWorks includes all mechanical and dimensional details and is exported to Simscape's multi-body to simulate real-time system behavior. The communication platform ensures secure data exchange between physical and digital systems with OPS, OPC protocol, and TAP server EX. A Siemens S7 1200 PLC programmed in TIA portal manages access motion, sensors, and spindle control, while real-time data enables bidirectional synchronization with the virtual model. This setup creates an interactive, safe, and repeatable digital learning environment, helping students reach theoretical and practical knowledge and promoting cognitive, person-centered learning. Here, this figure shows that as a virtual model of CNC router in SolidWorks environment. And the workflow is about these routers the CNC routers, digital twins transformation, digital twins creation. Define physical system, identifying mechanical components, axis X, Y, Z, and sensor of the CNC router. 3D modeling is SolidWorks. Create the full mechanical design, rails, motor, switch, holes. Virtual simulation setup, import the model into Simscape multibody for dynamic behavior simulation. Configure PLC hardware, use Siemens S7 1200 and define input-output modules, servos, and spindles controls. Program PLC in TIA portal. Develop ladder logic for motion, control, sensors, feedback, and safety routines. Establish data communication, integrate OPS protocol via PAP server EX for real-time data flow. Connect physical virtual systems, enable bidirectional synchronization between machine and simulation. Monitor and analyze, observe laser temperature, current, and motor performance in real time. Cloud and AI integration optional, link to cloud-based analytics or AI systems for predictive modeling. Educational application, use the system for virtual lab training, allowing safe, repeatable hands-on learning. In this shape, in this figure, show that us another samples of this type of transformation, digital twin creation stage is come from Professor Dr. Hasan Smaich works. These samples is come from that. In this type work, 3D design comes from Siemens NX and same mapping can follow in this works. And conclusion, digital transformation is changing education. Teachers are becoming guides. Digital literacy is now essential. Cognitive digital twins are on the rise. Learning is rapidly becoming personalized. Information filtering has gained importance. Source verification is essential. Student counseling is going digital. Digital security is fundamental element. Students are becoming producers. Information management skills are developing. Education should be individual, focused, flexible, and sustainable. Structured CNC router example demonstrated. Digital twin proven. The applicable, inspiring future work. Although these reasons, maybe in the future, these digital twins will be important for our education systems everywhere. That's okay for me. Thank you very much.
Thanks for your presentation. Did participant do you have any question about the study? No question. Thank you again. I wish you success
Thank you.
in your career. Next paper belongs to dear Maya Todorova.
Good afternoon.
Okay, now you can share your screen. Are you ready to present?
Yes, now I will share.
You have 10 minutes, please.
One moment.
Okay, your presentation is shown. We see
Okay.
your presentation. You can start your presentation.
My name is Maya Dubova, and I'm assistant professor in Technical University of Varna. I will present the paper application of the simplex method in the task for determining an optimal production program. Simplex method developed by George
Sorry,
Dancing.
your voice, your
about the
voice is
voice.
reflected.
It's a university.
Reflected. Your voice is reflected.
The simplex method developed by George Dancing in an universal approach for solving linear optimization problem. Many practical problems can be modeled using linear mathematical model. For instance, campaigns often face challenge in combining a viable resource to determine which products to manufacture to maximize profit while minimize cost. The problem associated with the process of maximizing profit are the process of finding optimal solution in production. This paper demonstrates the practical application of the simplex method in a specific economic problem. A mathematical model is created. The model has been added to simplex canonical form. The solution has been implemented using the simplex method and using computer software. The Solve tool from Microsoft Office Excel has been used for the computer implementation. Solver provides an opportunity to solve practical problems that can be mathematically described and represented as a linear or non-linear optimization model. On figure 1 is presented the main stages for solving linear optimization problem using the simplex method. The simplex method analyzes the vertices of the polyhedron using a standard model form and examines feasible basic solution. The process begins with an initial basic solution, which is checked for optimality. If the solution is optimal, the procedure ends and the solution is displayed. If not, the plan is improved by transitioning neighboring verdicts with a better objective function value. If the objective function is unbounded, the model is unsolvable and the procedure terminates. In papers is explained the theoretical part of the algorithms and illustrated it in one practical task. This is the task. A company plans to produce two types of products. Resources required for products are limited. The required resource per product type and their availability are given in table 1. The question is how many products of each type should be produced to obtain maximum profit. If it is no, that's the profit from the one product of type A and type B. First, we start with mathematical description of the problem. We entered two variables, x1 and x2. This is the number of the products of state A and B. This is the production program of the company, and the value of X1 and X2 is greater than or equal 0. Function Z is the total amount of profit for all manufactured products. The consummation of this of three types of resource for the desired products program X are given below. The task of finding production program of company is reduced to the following linear optimization model. The linear optimization model is reduced into simplest canonical form. To do this, we need to turn the inequalities into equalities by adding three additional variables, x3, x4, and x5. The initial basic solution is determinate. The model is transformed to the first simplex table. In first simplex table is calculate the value of function z and the estimate index estimate. Delta 1 and delta 2 is less than 0 and the point is not optimal. The objective function is checked for unbounded. The pivot column, pivot row, and pivot number are determinant. When we determine the pivot column, pivot row, and pivot number, we can improve this one. The improved one is created, and this one, again, we have to check for optimality. The one is not optimal because the objective function is checked for unboundedness. The pivot column and pivot number are determinant.
Sorry, dear Maya, your voice echoes. Okay.
I'm sorry.
Your voice echoes. I recommend using only one device at a time, a computer or a phone. Your voice echoes. Can you understand me?
Maybe have a problem with computer.
I can't understand you because your voice echoes. Okay.
I'm sorry.
Okay, continue on. Please go on.
On this second simplex table, we again calculate the function and the index estimates. The point again is not optimal. We have to create next one to improve previously. Here is the improved one, and we can say that the company will realize a maximum profit of 880 against level when it produce 120 products of type A and 80 products of type B. In the optimal solution, the variable x3 are equal to 0 and the variable x4 again is equal to 0. But the variable x5 is equal 50. These additional variables that we add to the model reflects the unused quantity of resource. Therefore, resource 1 and resource 2 are fully used. But there is a rest of 50 units of the resource 3. On this slide is presented how to find the solution with solver tools in Microsoft Excel. Solving the problem using the solver tool in Microsoft Excel require entering the model into an Excel worksheet. On figure 5 is presented how to enter it linear model into simplex canonical form. First we have to give the initial basic solution. After that, enter the function with formula. And the constraints is divided on two parts. Left part of constraints is given with formula and right part of the constraints. When model is entered in worksheet from the data menu, the solver tool is selected. The model parameters are defined in solver parameters window. After running the bottom solve, the optimal solution is displayed, allowing the user to save and generate a report. The optimization algorithm remains hidden for the user. This paper presents the algorithm of simplex method for solving linear optimization problem. We explain the theoretical part of the algorithms and illustrate it with one practical task. The method is applied to a specific problem related to the production. This problem we model as a linear optimization problem. We used a simplex method to find the maximum of the objective function respecting all the constraints in the model. The problem was solved using the solver tool of Microsoft Excel also. The simplex method is universal, applicable to a wide range of problems in the various fields. It operates in a sequence of finite iteration and allows for identified model characteristics, such as the existence of alternative optima and unsolvability. Thank you for your attention.
Thanks for your presentation. Dear participants, do you have any questions about the study? No questions. Thank you again. I wish you success, dear Maya Todorova. Next paper belongs to dear Bulut Keken. Dear Bulut Keken, can you hear me?
Hello, I am here.
Okay. You can start your presentation if you are ready.
Okay, now you can see my screen, right?
Yes, you have 10 minutes, please.
Okay, and my voice is all right? There's nothing wrong?
No problem.
Perfect. Hello, everyone. My name is Bulut Eken. I'm a graduated student in Gaziantep Islamic Science and Technology University. My paper is called Explainability-Based AI Governance, a legal framework analysis of ethical and social impacts. What is the main goal of our study? The main goal of the study is to build a bridge between technology, ethics, and law. I try to explain the issue of ethics on 3 important headings and also personal rights and freedoms. In my paper, it's in detail. We are not only talking about artificial intelligence as a tool, but also about its impact on society. Right now, we enjoy to use AI programs, AI systems like ChatGPT or any creative video or graphic things, but why I focus on explainability, because without it, accountability is impossible. Why did I focus specifically on explainability instead of other AI ethic topics? Because explainability is the bridge between ethics and legal accountability. Without understanding AI decisions, no regulation can be effective, we believe. That's why I am on this project. We cannot control AI system, so we cannot trust it. It's so normal for human being. If we don't know something, we always care about it. That was the starting point of our work. So explainability is not only a technical issue, it's the foundation of trust and fairness. And when we talk about knowing something, we usually get to use here a black box problem in AI systems. The black box don't just hide code, they hide responsibility. Many deep learning systems today make decisions that even their developers cannot fully explain it, how it made it. And this creates ethic risks, especially in healthcare, recruitment, or autonomous driving. For example, a car is deciding not to crash somewhere to protect the driver, but a pedestrian crossing the street, it can be. But who did this decision? We have no idea, no clue about it. This is called black box. So what does explainable AI actually do? We are on this especially. Explainable AI helps humans understand how and why an AI makes a decision. It improves trust, legal monitoring, and accountability. In short, we cannot explain AI. If we cannot explain AI, we cannot trust AI. While the problem with the autonomous operation and decision-making of these systems continue, the black box problem still will exist. Another topic emerged that bring us here today. What kind of ethical and social risks do we face when AI is not explainable? We face privacy violations, bias, and unemployment caused by automation. When AI decisions are not transparent, both justice and fairness disappear. So every technological process must come together with ethical responsibility. As I have stated in detail in my study, many organizations, unions, and countries are trying to be the rule maker, decision maker, and trying to limit on artificial intelligence. There are still some gaps about these rules, and there is no clear binding force will be prevent people from worrying. Well, so what are the main gaps around AI? After you had read the paper, especially the legal approaches part, you will see that there are many rules, there are many challenges in this, but no clear answer to this question. We cannot even decide, should I be treated to AI as a tool or a product or even a legal person? We couldn't even decide this. And this uncertainty makes accountability almost impossible. And when AI systems are not unexplainable, legal oversight becomes meaningless. So again, explainability is not just technical, it's a legal necessity. How far have international and national law gone on this issue? We have to talk about this also. So many things I wrote in the paper, but I will make it short. Organizations like OECD and European Union, and also Turkey, especially KVKK framework, these are the most important first steps for AI regulations. But I have to be honest about Turkey, that is in the early stage. KVKK focuses on data protection, while European Union AI Act introduces risk-based AI classification. Turkey's approach will likely align with European Union standards. But for all works, we may clearly say that no organization still doesn't make explainability a moderate rule. Our study suggests integrating explainability into the legal framework, not just mentioning it in principles. And governance model that we are proposing is built on 3 pillars: explainability, accountability, ethical by design. These together create an AI ecosystem that is not only intelligent, but trustworthy. Can ethics and law and technology really be connected? This is our point. Yes, and explainability is the key to make this connection real. If there will be a bridge, there will be a connection. Only explainability can do this, because answering why a system made a decision provides both an ethical justification and legal explanation. This is the message of our study. Explainability doesn't only reveal information, it builds trust. Finally, what conclusion we reach? What does trustworthy AI mean to us in this paper? Artificial intelligence should serve humanity, not replace it. Ethical and legal principles must guide every stage of its development. Explainability makes AI systems understandable, fair, and socially acceptable. In short, explainability is not just the heart of the trustworthy AI, it's the starting point of our proposed governance framework, which connects technical transparency with legal accountability and ethical design. Thank you very much for your time. If you'd like to ask anything, I'll try to answer. Thank you.
We thank you for your presentation. Dear participant, do you have any question about the study? Okay, thank you again. I wish you success.
You're
in the
welcome.
question.
And Mr. Yaşar, I will text you a message about my paper. Last night I noticed something. If you can aware about it, I will appreciate.
Okay, no problem.
Thank you very much.
Okay. Next paper belong to dear Abdullah Orman. Dear Abdullah Orman.
Hello,
Hello.
I am ready.
Okay, you can start your presentation. You have 10 minutes, please.
Good afternoon, everyone. My name is Abdullah Horman from Ankara Yıldırım Beyazıt University, and today I will present our study titled RC5-based Secure Communication Protocol Design and Intrusion Detection Mechanism for Wireless Sensor Networks in Smart Grids. This work was conducted in collaboration with Selçuk Yılmaz and Murat Derer from Gazi University. This research focused on developing a secure and energy efficiency communication protocol for wireless sensor networks (WSNs) in smart grid environments. We utilize the RC5 encryption algorithm conjunction with the OCB authentication encryption mode to ensure both confidentiality and integrity. Additionally, a parameter-based intrusion detection and prevention system was developed to detect and mitigate common network attacks. Smart grids rely heavy on wireless communication to manage distributed energy resources. However, WSNs are highly vulnerable to attacks due to limited resources and open wireless transmission. Our goal was to create a lightweight, robust security framework suitable for such constrained environments. As smart grids integrate IoT and sensor technologies, they enable real-time data exchange and efficient energy management. But this also introduces security challenges, attacks such as hollow flood, sinkhole, black hole, and civil can disrupt data transmission, reduce reliability, and waste energy. Therefore, design secure and low energy communication protocol is critical. The main objectives of study are threefold. One, to design a secure RC5-based communication protocol for WSNs. Two, to ensure data confidentiality and integrity while maintaining energy efficiency. Three, to develop and test an intrusion detection and prevention system in MATLAB simulations. Our proposed system consists three major components. One, the RC5 encryption algorithm integrated with the OCB operation mode. Two, MATLAB-based WSN simulation environments, and the intrusion detection and prevention mechanism. Together, these components ensure both data prediction and network stability. RC5 encryption algorithm, the algorithm is a symmetric block cipher with variable parameters. In our configuration, we used 33 bits word size, 127 bits K, and 20 rounds. This setup offers robust security while maintaining low energy consumption, as shown in figure. RC5 perform key expansions, encryption, low bitwise operations, and efficiency decryption. Ideal for resource-constrained nodes. OCB authentication encryption mode, offset codebook mode, combines encryption and authentication into a single process. It uses a random, nonce, checksum, and tag to ensure message authentication. These methods enable us maintaining a low computational cost while ensuring both confidentiality and data integrity. Refer to figure for the OCP process. To evaluate our protocol, we developed a MATLAB simulation. It consists of 100 sensors randomly distributed across a 100 meter by 100 meter area. Nodes are grouped into clusters of 10, each with a clustered hand that communicates with the base station. We measured parameters such as energy consumption, memory usage, and latency under different scenarios. The proposed intrusion detection system, IDS, continuously monitor network performance. The detection unit track packet loss, delay, and energy usage. The defense unit employs countermeasures such as not authorization, data authentication, packet flow control, and temporary slop nodes to converse energy and mitigate attacks. As illustrated figure, our system uses threshold-based detection. For example, hello float attacks are detected when message frequency exceeds the limit. Snowfall attacks are detected though abnormal energy consumption. Black hole attacks cause increased latency. Sybil attacks are identified by duplicated node identities. Once detected, malicious nodes are isolated. We compiled RT5 with IAS, RT6, and Blowfish algorithms for data size 256 to 2047 bits. Each node started with 1 joule of energy. We measured byte and latency and memory usage under both normal and attack conditions. The result demonstrates the high performance energy efficiency of RT5. RT5 showed superior energy efficiency, consume only 0.1 joules for 124 bits packet. It also required less memory, 1.8 kilobytes, and achieved the lowest latency, 0.25 seconds. These results confirm that RT5 is ideal for energy-constrained WSNs environments. Our IDS detected hello float attacks with 95% accuracy, single attacks when energy deviation exceeds 0.2 units, black hole attacks with 19% accuracy, simple attacks 92% accuracy. These results validate the system's strong detection and prevention capacities. Overall, the proposed framework effectively balances security and energy efficiency. By combining RC5 with OCB, we achieve fast authenticated encryption. The IDS enhances resilience against multiple attacks, thereby maintaining reliable network performance. In conclusion, our RC5-based protocol ensures secure and efficient communication for WSN's smart grids. It significantly reduces energy consumption while maintaining high data integrity and low latency. The instruction detection system ensures the overall network reliability. In future research, we plan to test this protocol in real-world smart grid deployments, extend into additional IoT-based environments, explore quantum-resistant encryption techniques, and adapt the model to heterogeneous network structures. This concluded my presentation. Thank you for your attention. I would be happy to answer a question you may have.
Thanks for your presentation. Dear participant, do you have any question about the study? No question. Thank you again. I wish you success in your career. Next paper belongs to dear Adele Otepola. Dear Adele Otepola. Can you hear me? Dear Adele Otepola. Maybe there is a communication problem. Okay. Next paper, we can continue with next paper. Dear Adem Koçyiğit.
Yes, Professor.
Okay.
I can hear
If you are
you.
ready,
Do you hear me?
you can start your presentation.
Okay. Then I'll share my presentation.
Then dear Adele'ye start.
Okay.
Okay.
I am sharing my presentation.
Please.
Can you see the presentation, Professor?
Yes. You have 10 minutes, please.
Okay. Thank you so much, Professor. And Dr. Adem Koçyiğit from Bilecik Şehir Vali University. I will talk about energy selective surfaces.
Hello.
Professor?
Hello. You can present after Adem Koçyiğit presentation, okay?
Okay, I just want to confirm you can hear me.
Okay.
All right.
Please go on, Adem Koçyiğit, your presentation.
Okay. Thank you, Professor.
Okay.
And I will talk about energy selective surfaces as superstrate usage of them on antenna for high power microwave protection. And this is my presentation plan. I will first introduce energy selective surfaces, the importance of them, and I will talk a little bit about motivation of the study. And I will talk design of antenna and energy selective surface structures. And I will talk about results and discussion on energy selective surfaces and my conclusion and future works. And this is my introduction. Manipulation of electromagnetic waves. This is the important things of this study. Some surfaces can manipulate easily electromagnetic waves. They can block or pass these surfaces. For example, especially superstrates can change electromagnetic behaviors easily. These layers behave like lenses and collecting the radiated or emitted radiation from antenna, making them sharper or focusing. Some kind of structures can be used for that aim, such as bare dielectric layers, metamaterials, frequency selective surfaces, partial reflective surfaces, electromagnetic band gaps, and energy selective surfaces can be used for manipulate electromagnetic waves. In order to make the antenna structure smaller, especially and more compact, especially the compact, these structures can be added on the top of the antenna or bottom of antenna to improve its electromagnetic behaviors. It is possible to antenna to increase their directionality, efficiency, gain, bandwidth, and decrease their size or dimension. Among others, frequency selective surfaces behave like filters and stop the electromagnetic waves in some frequencies and pass the electromagnetic wave in some frequencies, like a filters. We can see their behaviors here. Looks like filters, non-pass or low-pass, high-pass filters. Another important things in this study, high-power microwave protection, especially the antenna. Antennas need to be protected against high-power microwave or electromagnetic pulses because they are opening the door of the electronic structures. If you have any kind of EMP or HPM, your electronic circuits may be down. And if you have a UAV vehicle and it may be down, there are many things can be used for high power microwave protection, such as metasurfaces, frequency selective surfaces, or plasma confinements, ceramic-based film materials, large magnetoresistive materials can be used to protect against high-power microwave of antenna. Another way is to use energy selective surfaces to protect HPM. These are very popular nowadays in the literature. Many of the researchers work on these structures. Energy selective surfaces can reflect high-power microwave or absorb with immediately by triggering off the diodes as self-actuation. You don't need any other circuits to trigger your diodes. Energy selective surfaces typically designed two-dimensional array and integrated on front of antenna or vulnerable devices to protect them against high-power microwave or electromagnetic pulses. What's our motivation? We found these structures important for protect antenna against high-power microwave, but we aim at the same time to improve antennas' electromagnetic radiation properties. We use energy selective surfaces on antenna in two states. One of them is off state, and in these states, antenna can transmit radiation. However, if you have a two-phase EMP or HPN, this layer looks like or behave a kind of protection layer and reflect high power microwave back in on state of the diodes. How we design them? We used CST Microwave Studio to design energy selective surfaces for antenna. This is our antenna. We used Rogers RT5880, the thickness 152 millimeter. This antenna works at 2.45 gigahertz ISM band. And this is our energy selective surface. We have two layers, and its dimension 12 millimeter square unit cell dimension, and we used FR4 substrate with 1.6 millimeter thickness. You can see the unit cell structures here, and we used Flecoid theory to test our energy selective surfaces in CST software. What are our results? This is our antenna results, SB or return loss plots. You can see our antenna work 2.45 gigahertz band here. We have another band here, 2.85 gigahertz, but it's little. And you can see our radiation pattern. The main lobe magnitude is 6.45 with 5 degrees direction. The side lobe level of antenna is lower than minus 20 dB. The efficiency of antenna was obtained to be 88.25%. And what is our energy selective surface results? You can see the S parameters of energy selective surfaces when the diodes are on and off states. How we do on and off states? We used 2.5 picofarad diodes. You can see here in the structures. If we choose these diodes going to picofarad level and the diodes are off states, if we choose this value 0 and these diodes looks like on states, or another means they trigger it. Our ESS structures have two bands again. One of them is here, 245 gigahertz. Another one is 405 gigahertz. You can see our transmission bands here. And when the diodes are on states, we have a very good shielding effectiveness, approximately higher than minus 25 dB at 2.4 gigahertz and less than minus 20 dB for a wide band from 0 to 4 gigahertz. Another important thing is insertion loss. Our insertion loss for transmission is low as a minus 0.39 dB. Our results is very good agreement with literature. And what will we do? What we do after that? We used our energy selective surfaces as an array on the antenna by a distance of 32 millimeters as a superstrate layer. And you can see our return loss graph here and our gain graphs. You can see here in reference antenna and antenna superstrate system has almost same return loss pattern. And what happens when the diodes are off states? Our gain increased from 88 to 12 almost. Our radiation pattern, you can see here, is very good again. Our main lobe magnitude increased from 6.45 to 6.71. In the case of triggering or diodes are on states, the transmission is decreased, as you can see here. Most of radiation come back to antenna. We can see our results here, the reference antenna, the return loss of reference antenna, and antenna superstrate system. For diodes are off states and on states. Most of things is good for off states of diodes, this superstrate. The gain increased, efficiency decreased a little bit. However, our bandwidth increased a little bit. In the case of on states, these are decreased, the gain decreased, efficiency decreased. It means our antenna protected against high power microwave. Right. What is our conclusion? We designed double layer energy selective surface for two goals: enhancing antenna gain and in the presence of low power electromagnetic waves, and ensuring its protection against high power microwave attacks. The results revealed that our structures, our superstrate, energy selective surface superstrates, boost antenna gain up to 12.24 dBi. The transmission band and other antenna parameters almost remain without change. The energy selective surface shields antenna against high power microwave when the diodes are in on the on states. The proposed antenna with energy selective surface structures can increase antenna performance, energy selective surface, and at the same time behaves like a protective layer against high power microwave. We are trying to increase transmission band and increase shielding effectiveness of the energy selective surfaces. And we hope we will fabricate energy selective surface and antenna together, and we will confirm our results experimentally. This is my references. Thank you for your attention. If you have any questions, then I can try to reply it. Thank you.
Thanks for your presentation. Dear participant, do you have any question about the study? Okay, no questions. Thank you again. I wish you success in your career.
Thank you, Professor. Thank you so much.
Last paper of the session belong to dear Adele.
Yes, can you hear me now?
Yes. If you are ready, you
Okay.
can start your presentation.
Okay.
You can share your screen.
Can you see my screen?
Not yet. Maybe it's coming.
Okay.
Yes, it's shown. You have 10 minutes, please.
Perfect. All right. Good day, everyone. My name is Hadelaye. I'm from Nearest University, Northern Cyprus. I'll be discussing today about solar energy advancement and deployment strategies in Kwara State, Nigeria. This is a comprehensive review. I have here an outline of the things I'll be presenting today. Pardon me.
Dear Adelaide,
Yes.
we can't hear you.
My screen is having a problem. Just a minute, please.
Okay.
So here are the outlines of my presentation.
Yes, your presentation is shown. Please continue.
Nigeria enjoys an average of 5.5. Please let me start all over again.
Okay.
Nigeria enjoys an average of 5.5 kilowatt hours per meter per square day of solar irradiance, which is one of the highest African's irradiance. Yet less than a million households rely on solar energy, and this is the present state of what is affecting energy poverty in Nigeria. In particular, Kwara State, which is the Middle Belt region in Nigeria, has a high potential but limited uptake regarding this adaptation of solar energy. Now, this paper reviews exploits opportunities, barriers, and governance structures. Over here in the diagram, we can see the map of Nigeria, and we can see the highlighted part of Kwara State, which is the middle belt of Nigeria. In the paper, we have a scientific gap, which we try to bridge. Most solar studies in Nigeria focus on Lagos and Abuja. Kwara remains understudied with little evidence on policy implementation, adoption barriers, and cost structures. This review addresses the gap. I must point out that Lagos and Abuja happens to be one of the most advanced cities or regions in Nigeria, Lagos being a business hub and Abuja being the capital of Nigeria. In our research objectives, our objectives are threefold: to assess solar potential in Kwara, to identify barriers to adoption, and to evaluate policy frameworks with comparative insights across the state. The methodology is conducted in the systematic literature review, supported by datasets on the irradiance, adoption barriers, and the solar home systems costs. A comparative analysis across Lagos, Kano, and Kwara applied to contextualize our findings. We can see here in the diagram the solar potential in Kwara. This chart shows that Nigeria's average solar irradiance from 2020 to 2024, ranging from 5 to 6 kilowatt hour per meter square per day. Kwara's consistent irradiance demonstrates strong technical viability. Satellite data confirms average Kwara's irradiance per day to be 5.8, which is sufficient for rural electrification through the solar home systems. This is enough for Kwara State to have their own rural form of electrification. Now, going to the barriers that hinders Kwara State from adapting the solar adaptation, from adapting solar energy, the main barrier include high upfront cost. We have weak policies. We have lack of awareness and technical expertise gaps. These are similar to Kano, but they are more severe compared to Lagos. We can see here in the bar chart the barriers to solar energy deployment in Kwara State according to each categories and the percentages that represent the severity scope. Now, based on the adaptation barriers comparison, this chart shows that we can see that the Kwara aligns more closely with Kano, while Lagos shows lower cost barriers due to urban financing schemes. Like I said earlier, Lagos is a more populated area which is subject to high financial schemes for supporting projects which can adopt solar energy. But in the map of Nigeria, Lagos happens to be in the southern region and may not have this much availability of solar energy compared to Kwara State. A cost breakdown of the solar home systems, which is one of the adaptation barriers, we can see here in the pie chart that illustrate that solar panels and batteries account for nearly 2/3 of the SHS cost, making affordability the primary deterrent. Now, the policy and governance framework, which can ensure the governance in which the adaptation of solar energy could be possible. We see here we illustrate how federal policies should cascade to state and local implementation. In Kwara, weak local governance and limited funding stall progress. So this flow chart enables the from the federal government down to the monitoring and evaluation possible for solar adaptation in Kwara State. In our results, our reviews strong technical viability but poor adoption, less than 5% penetration in rural Kwara. This shows a misalignment between potential and policy execution. Lagos exhibits the highest adoption rate attributed to higher income levels, urban awareness, and better policy incentives. Kano shows moderate adoption driven by solar demand for off-grid use, but hindered by affordability. Kano and Abuja being the capital of Nigeria, happens to be in the same region and almost same population range. In the recommendation, we recommend government-backed subsidies, technical training, awareness campaigns, and robust monitoring frameworks. Evidence from Kenya shows adoption increases by 35% under similar strategies. In summary, solar future is technically viable, but practically constrained. Bridging financial and policy gaps will accelerate adoption and support Nigeria's 2060s net zero goal. Here are a few references used in our review. All sources are from peer-reviewed journals and energy reports, which follows the APA referencing standards. I acknowledge my co-authors for the support as well. And thank you for listening.
Thanks for your presentation. Dear participant, do you have any question about the study? Okay, no questions. Thank you again. I wish you success.
Thank you very much, sir.
Dear participants, the session is over. Thank you for your attending. Thanks for your contribution. I wish all participants continued success in their career.
Thank you very much.
I'd like to end this session. Have a good day. Good luck.
Thank you. You too.
Very good day, Professor.